So this specific skill is not a very popular one because we're used to taking two fractions and bringing them together. So 5 over 6 common denominator. It's not often that we go from here to here where I give you a fraction, for example, 4 over 7, and ask you to make two fractions that would add or subtract. But sometimes this skill is helpful. So let me just show you. So when you split a fractions, 4 over 7, there's many ways you can do this. It depends what you want. You can make it a sum of something or a difference of something. But in this case, notice how I split the fraction into two common denominators here. So the numerator can be whatever you want. For example, I think two numbers that add up to give you 4. In other words, it could be 2 and 2, or it could be 3 over 7 plus 1 over 7. There's many ways. Or let's just say you want to be a subtraction sign. So denominator is still the same. But you can have, for example, 5 minus 1. So there are many ways to split a fraction. So when it comes to trig, let's just say I had a sine theta plus a cos theta all over a cos theta, right? Now some students will just take this up. They just, oh, cos, and you're left with sine theta, which is incorrect. So if you want to simplify it, you would have to take the fraction and split it into two pieces. So notice how I'm carrying the denominator in both the sine and the cos. So I'm just splitting the fraction, maintaining the common denominator. And then what's after? Well, this fraction, there's nothing much we can do. Sine over cos plus, but this fraction here, cos divided by cos, is the same thing as 1. In other words, I'm breaking up the fraction into two pieces. And since we're talking about identities, do you remember what sine divided by cos is? How can we rewrite this out? It is the quotient identity. So I'll put here QI for quotient identity. Okay, let's start off with our first trig identity. So over here, you have a left side and a right side. And the point of this is to prove whether the left side is equal to the right side or the right side is equal to the left side. So in most cases, depending on the teacher, you're going to have to pick a side to work with. The question is, well, which side are you going to work with first? Ideally, you would like to work with the side where you can actually do something or do some sort of algebraic operation. In other words, I'm going to be choosing the left-hand side. And the reason why is because I got two separate fractions. Well, this is the same thing as over 1. I have two separate entities and I can actually add the fractions. And also, if you look at all the identities over here, notice here, in the quotient identity, tan is the same thing as sine over cos. In other words, I can change the tan using quotient identity and sort of bring in the sine and cos, which I want to have eventually. So I'm going to start it with the left-hand side. So you actually write down left-hand side is equals to tan theta plus 1 over tan. So you're just starting with the statement, the side that you want to work with. All right, then the question is, what's next? What are you going to do with this? You have a choice. You can add these two entities directly, or you can use the quotient identity and change everything in terms of sine over cos. It is up to you. So I'm going to write the following down. I'm going to put here quotient identity. Basically, I'm actually describing my steps. I'm going to use the quotient identity to change the tan into sine over cos plus 1 divided by sine over cos. I prefer to write a division statement like this, side horizontally rather than vertically, because that will allow me to actually deal with a division horizontally. In other words, when we divide a fraction, remember, you multiply by the reciprocal. I'm going to take the reciprocal of this, all right? And we know that. So over here, I'm going to write down, I'm just going to take the reciprocal. So I'm just writing down the steps that I'm doing from one step to the other. And then afterwards, well, 1 times anything is still the same thing. Okay. So I'll put here, simplify. I'm simplifying the right bracket. So now if you notice here, oh, look at my left-hand side. It started with a tan, but now I have some sines and cos, which is great because look at the right-hand side. I'm aiming to have some sines and cos, but notice how they're not exactly the same thing. This does not look anything like this yet. So we're getting there. So now we have two separate fractions. And what do we do when you have two separate fractions? Well, you're going to have to find a common denominator. So you have cos and sine, and the common denominator was just to take them and multiply them together. In other words, my common denominator will be cos and a sine, just to bring them together. It's sort of like the common denominator between 2 and 3. Well, what's 2 and 3? 6. Well, how'd you get 6? You take 2 times 3 to get 6. So that's one possible way of thinking it. So in this case, I'm going to put cos, theta, and sine theta. It doesn't really matter which one comes first. All right, so now I'm going to write the sine here. So sine theta. The question right now is, well, what's the extra piece? What's the extra piece? So you had cos before, but now you have an extra sine. So what that means is you're going to have to multiply the top term by sine. So what's sine times sine? Well, it becomes sine squared. So I'm just going to put the steps here before I actually simplify it. Now the right hand side, let's compare this one here to this one here. Well, you had the sine and the sine already, so what's the brand new term that you added? Oh, it's a cos. That means you have to multiply the top and the bottom by cos. In other words, you're going to have to take the original cos and multiply it with another cos. So I ran out of room, so I had to erase the previous step. So this is where we had previously. And once we find a common denominator, let's actually put it all underneath the same LCD, common denominator, and let's actually start to simplify this. Well, what's sine times sine? Well, it's the same thing as sine square plus what's cos times cos? It's cos square. In other words, I'm just going to write down SIMP for simplifying, okay? And you notice, well, miss, this doesn't even look exactly the same thing as this one up here. I'll use the yellow one. So notice how they're still different, but we're getting closer because if you look at the denominator, what do we have in the denominator? Oh, I have a cos and a sine. Oh, look at the original one, cos and a sine, or sine and cos, it doesn't really matter which way. But miss, the question is, why is there a 1 here and why is this like some complicated looking expression? Now keep in mind, look at the identities up here. Which one of these are you going to be using next? Well, I think you're going to be using this one over here because this is the Pythagorean identity that we proved in the previous slides. So sine squared plus cos squared is equals to 1. That means this entire numerator will become a 1, and now we end up getting the following. So I'm just going to write my steps here. I use the Pythagorean identity. So you're telling me what you are using to change from one step to the other step. And now if you notice here, we have 1 over cos theta. It's messy, I'm sorry. 1 over cos theta and sine theta. And now that we can say that, oh, it is equals to the right-hand side, and therefore left-hand side is equals to the right-hand side. So in terms of proving identities, there is a lot of algebraic skills. And the question is, miss, is this the only way to prove it? Can I not like use quotient identity first? There's many, many different ways. So your story, when I describe identities, once upon a time, your once upon a time may be different from my once upon a time. The journey of your story could be a different journey than my story. But if we all do the proper algebraic steps, meaning like we add or subtract or factor, whatever it is, we will all end up happily ever after, meaning we will end up proving left side is equals to the right side. All right, so here we have another identity. So we're going to go through a couple of them. So let's look at the left-hand side versus the right-hand side. So the left-hand side is very simple. It's just tan x. But the right-hand side is a bit more complicated. So sometimes it is ideal to use the complicated side because you can actually do something with it. It's harder to go from something simple to something messy versus a messy to go to simple. And so in this case, I'm going to start with the right-hand side. So in other words, sine x plus sine square x all over cos x bracket 1 plus sine x. All right, what can we do here first? Well, I'm looking at the numerator and something sticks out. What sticks out is that, oh, I got two terms and they both have a sine x. In other words, I'm going to GCF factor. In other words, I'm going to factor out the sine x, a single sine x. And what am I left with? Now keep in mind, when you factor a sine x, you're actually, I'll put in blue, you're dividing sine x. You're dividing sine x. So in other words, you go from the first term, what's sine x divided by sine x? It's not 0. It is actually 1. Plus, over here, what's sine squared divided by sine? Well, I remove a sine x from the bottom, I remove a sine x from the top. I'm still left with a single sine x. But don't forget to write your denominator because you haven't done anything with it. And what do you notice about the bigger picture right now? Right. What you will notice right now is, notice how you have these two things. I'm going to scribble in yellow. They're exactly the same. So what we can do right now is, because everything is in factored form, we got something times something, something times something. Now we're in a position to actually reduce this fraction. In other words, what we're left with is sine x over cos x. So from here to here, I'll put here SIMP, simplified. The question right now is, well, miss, this is sine over cos, but isn't our whole point to make it into tan? Well, I'm going to ask you to look at the identities up here. Well, which identities are you going to be using that kind of looks very similar to sine over cos? We'll be using the quotient identity. In other words, this right-hand side will become a simple version of the sine over cos, which eventually becomes tan. I don't have any room. I've got to move to the side, tan theta. So from here to here, I'm going to write down, I'm going to be using the quotient identity. And now, because I changed all my entire right-hand side, I did some work, and I end up with tan, I can right now say that this is equals to the left-hand side. Proven. So in this example, we're going to work with the left-hand side, because I can see that the left-hand side is a bit more complicated. It's more bigger in size, I assume, and I can actually subtract the two rational expressions here. So let's start off with this one here. So over here, the left-hand side is equals to 1 minus sine x minus 1 plus sine x. So in other words, we need to find a common denominator to combine these two expressions together. So the common denominator would be just to bring them together. So you have 1 minus sine x, 1 plus sine x for the first fraction. The other one, which I need more room, 1 plus sine x, and here's 1 minus sine x. In other words, I'm just going to put in green the new one for the first fraction. So this is my new one here. Whereas the right-hand side, this is my new fraction here. Or I mean new factor that I put in the denominator. In other words, I'll put the 1 here from the original. In other words, you're going to have to compensate the numerator with the new one that you inserted in the denominator. Over here, I'll use red. So I'm going to put in brackets 1 minus sine x. So now we're in a position to clean this up, meaning we're going to simplify this. So over here, I'd like to write my steps. I'm going to put here LCD for common denominator. And then I'm going to write a bit more smaller here, because I'm running out of space. So 1 minus sine x, 1 plus sine x. I'm going to bring this together. So I'm going to just multiply this out. Well, anything times 1 is still the same, so we're left with 1 plus sine x. Now this one here, you have to be careful because we have not a positive one, but a negative one, meaning this negative one is going to be distributed into all of these red terms here. So 1 times negative 1 is negative 1. Negative times a negative is a positive sine x. And then I'm going to simplify the numerator. So let's collect like terms. 1, negative 1 is gone. Sine x plus sine x is 2 sine x. So collect like terms. Now the denominator, you have a choice to leave it as it is or expand, but I'm going to expand this. So you're going to distribute this many times, or for those that can recognize, this is a difference of squares. So once you expand, you get this piece here. So if you notice right now, you're probably wondering, well, miss, it doesn't look exactly like this one up here. You're not even close. Look at the numerator, miss. There's a tan. Over here you have a sine. Miss, you have a cos. You have a mixture of a sine and a number 1. What's the next step? Well, we're going to have to look carefully at the identities in the top right-hand corner. So let's have a look over here. So I'm going to focus you on this one over here. So if you notice here, we have in the denominator 1 minus sine squared. And over here, we don't have 1 minus sine squared, but we can actually reformat this. Recall from previous slides, I'm just going to move the sine square over, leaving cos square theta is equals to 1 minus sine square theta. So this is a reformat version of the Pythagorean identity. So in other words, this thing here, 1 minus sine squared, is the same thing as cos squared. So in other words, I'm going to keep the numerator, but change this whole thing into cos square theta. I'm going to put in arrows, my steps, pi. Okay? I think most of these steps over here is all SIMP to simplify. And if you notice right now is we're getting warmer towards what we want, because we have a cos right now in our denominator. But the question, miss, is, well, you have a single cos. Here I have a double cos. Well, let's keep on going with this. So what I'm going to do right now is we're going to split the fraction up. And you're wondering, split the fraction? Well, keep in mind when you multiply fractions, you multiply top times top and bottom times bottom. So in other words, I'm going to split the denominator into two fractions over cos x. Because remember, denominator times denominator will give me cos squared 2 sine x times, well, you need to put something here. It's not a 0, it's a 1. So put here, we're going to reformat the fraction. And now what do you notice here? Well, hold on. What do you notice here? Sine over cos is the quotient identity. In other words, I have to go backwards. I don't have enough space. So put here, I'll put an arrow here. 2, this whole thing in blue becomes tan x. And I'll put here 1 over cos x. And now we're pretty much done because we have exactly what we have on the right hand side. But miss, you have two brackets here. What am I going to do next? Well, we just have to simplify this. Remember when we multiply fractions? Top times top, bottom times bottom. So you have 2 tan x. Anything times 1 doesn't change, and now we are done. So I'll put here equals to the right-hand side. Now, when you do identities, you shouldn't do it the way that I do. It should be going from, ideally, top to bottom and not left to right in all the way convoluted way. I just don't have enough space.